So Chris is going to show us magic. So for years, we'd have like this big giant list of steps to walk through for how to like grab different kinds of data, put it in different parts of WMS, manipulate it, work. And then Chris would work into like the wizard that walks it all through for you. So Chris is going to demonstrate wizard for us, and then we'll do lunch.
All right. The wizard is kind of really, it's kind of GSHA for dummies. You ever heard those books? You remember those books? Do they still have those? The C++ for dummies or Python for dummies? Okay. Anyway, the wizard is kind of GSHA for dummies. So if you're a dummy like me, and you can use the wizard. So what I would say is, I would just always, if you're creating a GSHA model, just always start out by using the wizard. It's probably a good idea to just start out, especially if you're new to WMS or new to modeling in general. Start out by using the wizard. It's going to step you through all the steps you need to create a model. And the wizard is this button up here at the top of the WMS screen. There's this little wizard hat on top of this is what we call a topologic tree that the wizard hat is on. That's why that icon looks like that. But it's a wizard hat. It is called the Hydrologic Modeling Wizard. Click on that button. It's going to bring you into this window. And this steps you through the process of creating not just GSHA, but any hydrologic model that you're going to want to create in WMS, you'd use this wizard. But for our purposes in this course, we're creating a GSHA model. So I'm going to start by defining a project file name. And I don't know that you don't necessarily need to follow along or try to keep track. I mean, the main thing is just to try to understand what I'm doing and where I'm getting data and stuff. That would be the best. If you want, you can follow along. Let's go to Aaron. I hope it's okay if I save this on your computer.
Yeah.
So I'm going to make a file here just call it Norman. We're in Norman, Oklahoma. I'm going to save that file out. That's just saves the WMS project. We're going to define a projection, and does anybody remember what UTM projection we're in? Maybe I'll just select state plane. We're in 14. So to define your projection, you're going to go here to this global projection button. That's going to bring up this projection window. If you type in UTM space 14 here, it's going to come up with several projections. The projection I like to use is this NAD 1983 UTM zone 14 north. You just don't want to select one that's in feet. You just want to make sure it's one that does not say feet. And the way, it's kind of actually hard to tell if you're working in feet or meters, but the way you tell is in all this garbly goop down here, mumbo jumbo, this stuff, it says units or meters right here. Unit, meter, 1.0. That means we're working in meters. And you may not know that, but you can just look down here and toward the bottom of all this text it says units, meters, 1.0. And then you know you're working in meters. Hit OK. Make sure also that your Z values, your Z units are set to meters. And the datum doesn't necessarily matter that much, so just leave it local. And then we're going to define a project boundary. So to define the project boundary, you select this define button. It's going to bring up this window. And oh boy, Aaron. It's not working for me, but did it not work for you before too?
It didn't work.
Okay. Well, that could be a problem. So a couple things. When you first bring up this window, you might get a message that it's going to modify your registry. WMS is going to modify your registry, and you might have gotten that message. If you get that message, be sure you click OK. You may let it modify your registry. If you don't get that message, then it won't set up the program correctly, so you won't see a map. Maybe that's what Aaron did, or maybe it's just the Army Corps of Engineers has locked down their computers, so you're not able to change the things you need to change to get to this map. But you're going to want to be able to see a map in this window to be able to download data.
I got it.
Yeah. So I guess what I could do is, let's see. Okay, so there's a couple workarounds. Let me close out of this. My workaround right now is I'm going to select this Get Online Maps button. If I click on that, click OK. Yeah, okay, whatever. It's probably gonna give me some warnings. I'm gonna click on Google Maps, and that way I get Google Maps, some Google Map into WMS. See what comes up. Okay, and I'm probably in the middle of the ocean somewhere. I'm gonna zoom out. Keep zooming out till I find something.
You're 1 degree.
Oh, there we go. Okay. So we were at 00, which is kind of off the coast of Africa. 0 degrees latitude, 0 degrees longitude. So this is tricky, but what I need to do is change my display projection. I'm going to reset that to my correct display projection, which is zone 14 north. Then we're going to go over here to Oklahoma.
VPN and.
So if you VPN in, then you
I
can get.
forgot VPN. I think the word.
Okay.
No.
Anyway, let's just keep going. So here's Norman. I'm going to just delineate a watershed in this area. So to delineate some watershed here, I have to first get the elevation data. So to get the elevation data, in the wizard, if I would have been able to select the area, the boundary using this window here, then the next step I can use, the next step is where I can select this download data from web services. So I can download data from here, but that's based on these coordinates I've defined in this window. So you want to, if you're in this window, as long as you can get to that, as long as you can see where you are here, then you should be able to go through this wizard and continue on here. But
You can cheat a little bit here, so if you look down in the lower left.
in the wizard, oh, over here, in the coordinates here,
You've got
right here.
It's here.
Yeah, so you can take those coordinates and put them in the window. But I'm just gonna, for me, I'm just gonna use this get data tool, which does the same type of thing, and then I can select the area where I want to get data. Let's just select this area here. This is a pretty big area. I just want to try to get an entire watershed area here. And there's a couple of different, well, I guess this one for some reason just has the worldwide elevation data. We'll just use that. And we're going to select a name for it. So I'm going to call this Norman. And it's going to define some name for that file that it's going to download. I'm going to select a little higher resolution. Let's go down to 31 meters. And you can go down to 7 meters, 3.9 meters, I guess is the highest with this data set. But I'm going to select this one. That's going to get my elevation data. And I need to convert to use that to create a GSSHA model. I have to convert that to a DEM. So I just right click, convert to a DEM. Hit OK. It's going to convert it to a DEM. Now, along with the elevation data, you might also want to get some. One thing when I convert it to a DEM, it brings this icon into the terrain data model. That's my actual DEM and WMS that I can use to do my GSSHA, get my GSSHA elevations and stuff. You also might want to get some land use and soil data. So to get the land use and soil data, you can either get it from the wizard if you can do that, or you can just use the get data tool and just go to this window, this data service options, and you can get your land use data. There's different formats for the land use data. One is this gridded format, and that's the one I usually use. If you go to advanced, it actually has the gridded format all the way up to 2016, I guess, and well, actually 2019 was the latest revision of that.
Is that just the national land cover thing?
Yeah, so it's the national land cover from the USGS. We'll just call this Norman. So we can get that land cover data. We can also get the soils data, and all this data we're going to use in GSSHA. So there's the land use. One thing with the land use is you're going to want to right click on that and just tell WMS that that is a land use grid. So you say convert to land use grid. And that just makes this icon up here under the map data. And then you also usually want to get soils data. So I'm going to download the soils data also. And the soil data you could download the whole state. That's a StatsGo statewide soil survey data. Or you can download the SurGo data, which is more county-wide data. It's a little bit better resolution than the statewide data. And it's probably going to download several soil shape files. We'll call this Norman also. So WMS will go and download all these soil shape files for this area. And so that's all my soil data. I'm going to turn some of that off so we can see what's going on a little bit better. Okay, so once we do that, once we get all of our data into WMS, that's the gathering the data step. Then we can go to the back to the wizard. I'm going to go back to the wizard because I want to use the Hydrology for Dummies. And so we've already gone to the download data step. We're past that. Now we want to run this Topaz. So there's a program that WMS has called Topaz that gives me, the purpose of Topaz is to figure out where the streams and where the flow directions are going in my watershed. I'm just going to run Topaz here. It runs, and WMS shows me these blue lines that give me the location of streams in this area. So, I don't know, where's Norman anyway? Let's turn off this elevation data, or you can actually change the elevation data. So we're like right around this area maybe. Maybe that's the watershed we'll do. So to do this watershed, you're going to first create an outlet point. Just do one, maybe right here. Then you're going to delineate the watershed. Click on this button to delineate the watershed. There's the watershed. There's some specific things that we'll talk about probably later, but that's how you do the delineate the watershed in the wizard. You're going to run, then we're going to want to create a GSSHA model. So these are all the models that are supported, but we're going to create a GSSHA model. So you initialize, select GSSHA, select initialize model data. That creates a GSSHA model down here under the 2D grid data. And then we, so for GSSHA models, usually what you'll want to do in a GSSHA model, you want to define some kind of the hydraulic model for GSSHA. And to do that, you'll want all of your streams going downstream. And to make sure your stream is going downstream, there's a few tools that are here. So the first tool is you want to redistribute the vertices on your streams. Yeah.
So this, I'm sorry if you said it already, but that size of the watershed, like, is that a top 10 or like, how does that get determined? Is it when you determine your area initially, that determines how big?
How did the watershed boundaries get determined?
Just from this, we're selecting.
It's just from the outlet point. So I've defined this outlet point, or some people call it a pour point. It's located right here where the watershed intersects, or the river intersects the highway, Bishop's Creek.
We've got a presentation that walks through the design process.
Policy too, yeah.
Thank you.
Yeah, let's just take some bits.
So, in GSSHA, you'll want to define some kind of stream geometry for each of these streams. And so I could just, I don't know how big these streams are, but I'm just going to define some stuff. So we're going to say define a Manning's end value, define a depth, like maybe 1 meter. Bottom width, we'll just do 2 meters. Side slopes, we'll do 1 to 1. And that's just the basic parameters you need for a trapezoidal stream channel in GSSHA. It's going to ask me to renumber some things, and then I want to redistribute my vertices. So to redistributing vertices, that means just changing the vertex, the node, the spacing on the stream segments. So they are whatever kind of, they're similar to the resolution of whatever our mesh resolution is going to be, or our grid resolution. And so let's say we want to make like 100-meter grid spacing. So I'm going to make these stream segments, I don't know, like 100 meters. Just try 100 meters for the average spacing. And then what we wanted, the only other thing that we need to do is, and could be a lot of work sometimes if you have a lot of streams, you want to smooth the streams. And to do that, what I usually do is just select a line of streams. So you select this select stream tool and then just select the stream segments that I want to smooth. And then you'll see this window pop up. Select smooth selected stream segments. Sometimes, so you'll have some higher elevations, some lower elevations. You just want to try to get everything going downstream so you don't have any blockages in the streams, because water doesn't flow uphill. And a lot of times some of these elevations are going to be based on the tops of roadways maybe. So you'll probably want to stick with the lower elevations for your streams. But I mean, Chuck would be able to tell you better about how to get the right elevation. So I'm going to just select some of these lower elevations. And you might want to be a little more careful when you're creating another model, but and then I'm going to select this tool that interpolates between the selected points. And that's just gonna make sure everything is going downstream between those points, so make sure everything is going along those slopes that I've selected. Those are kind of my slope break points. Anyway, so that's my that stream segment. Then I want to go to my other stream lines. So I need to select this line of streams, select smooth, and just make sure these are fairly smooth. So I'm going to go over I'm just going to do a straight slope maybe between these points. Interpolate. And then I have one more little segment down here. So I'm holding down the shift key to unselect and then select this downstream most and select smooth. And then this is just a few different points on the stream. So I'm just going to move these where I want them. And then I can create my GSSHA grid. So I think we said we were going to try 100 meters for my grid cell size. And then define that, select create 2D grid. And then this window comes up that I want to interpolate my elevations from my DEM, and I want to use my GSSHA coverage stream. So that's the elevations that I defined in that when I was smoothing those streams. It's going to use those for my grid elevations wherever I have a stream. Okay, so I hit OK. Delete existing background DEM. I'm going to leave it there, just hit no. And so now I have my GSSHA grid here, and there's a lot of other stuff. So I can set a starting and ending time for my simulation. Let's just do a one-day simulation. Set my job control data. I'm not going to bother too much. Later on, I think we're going to talk about getting index maps and things. So I'm not going to show you how to do an index map. Although, well, I might as well. It's pretty fast. So to do an index map, you just want to join the NRCS data for each of these soil types. And then you can create what we call a soil type coverage. That's this create coverages button. And map some of these attributes from the soil. So it'll map the hydrologic soil group and then some of these parameters. And the main thing you need is this soil texture for setting up a GSSHA model. It's going to map those parameters to the coverage, the soil type coverage, which is located up here in my Project Explorer. And then what I can do from that is I can create index maps. And so index maps is how GSSHA uses index maps to determine different roughness values of different parts of your watershed, different infiltration values for different parts of your watershed, and things like that. So to compute my index maps, I can click on this button. And usually you'll want a soil texture index map. I'll just call that soils. And you're going to want to map soil texture to that. And so there's my soil index map. And you'll also want a land use index map. Call that LUse. And that's going to use my land use grid that, remember I had that land use grid that I had downloaded earlier. So these are my land use values for this grid. And also the other thing you're usually going to want is some kind of uniform index map. If you're just getting a model up and running, a uniform index map is really useful. The way you create a uniform index map is you click on this data calculator, click and say you want to create an index map, call it uniform or whatever you want to call it. and just put a value of 1, value I usually use, and click compute. That's going to make an index map where the whole watershed has a single value. Yeah, so don't worry about doing all this.
This is just a preview. Yeah, this kind of.
And then you can use that, any of those index maps in this window, where you define your managed roughness values, your infiltration values, if you're doing infiltration, your groundwater values, all that stuff can be defined in this. This is the map, GSHA mapping tables. And I'm just going to use that uniform index map to find a constant roughness value of maybe 0.1 for my whole watershed. And just try that. The other thing I need to do is make sure my job control parameters look good. I'm just going to leave those how they are for now. One thing I might want to do is turn on my channel routing. That'll make it so I have my hydraulic model, and it'll give you a better hydrograph if you have your hydraulic model running with. So each has a 2D hydrology and a 1D hydraulic model. You want to run both of those usually to get a good hydrograph at your outlet of your watershed. The next thing I need to do is define my precip. So to do that, I'm just going to use what we call a SCS or an NRCS type 2 24-hour distribution for my precip. And this is the way that looks. That's the precipitation distribution over 24 hours. And to get the value, if you're just doing a 24-hour precipitation model, you could go on to, there's something called NOAA Atlas 14. I'm sure those who work at the National Weather Center probably know about NOAA Atlas 14. You go on there and find the precip value. I'm not going to go on there because it takes some time trying to eat lunch. So I'm going to put in some value. I don't know, maybe it's 10 inches for a 24-hour, 100-year storm or something. So put in, what's 10 inches in millimeters? Is it 3 inches?
They're like 50 mil.
50 mil, put it in 50 millimeters.
Yeah, put it in 50 millimeters. Yeah. It's only got 1 minute left. Okay.
And then we're gonna,
1 mil.
gonna clean up my model. So you can turn any of these off that you want or leave them on or whatever. Clean up your model. It says no errors were found in my GSHA model. That's always a nice message. That doesn't mean it's gonna run, but it means no errors were found in WMS. This is clean dam running, smoothing out some what we call pits or digital dams in your watershed. We're going to save this model. Let's call it Norman.prj. And we might as well run it. Let's try running, see what happens. I don't know how long that's going to take, but hopefully it'll take, just running overland flow and channel. It's not very big errors.
Is this for how many days?
This is just for one day. Okay, it's all done. We're going to close this. I'm going to close this window just so we can see a little bit better. And then I can look at the hydrograph. There's the hydrograph. I can also look, so the default is WMS will output, or GSHA will output the depth at each times, or each, whatever time interval you specify, and you specify the time interval in the job control. You go to the output control. So it's right now it's set to write out everything every 30 minutes of my simulation. So every 30 minutes I can view the overland flow depth of my watershed. So we're just gonna run through this so you can kind of see the water coming in, and then it's gonna eventually run out. Probably end up being some ponds toward the end of the simulation. Anyway, we could run it longer. Maybe we should run this one for 2 days or something.
Yeah, it didn't quite all run off, but you know.
Anyway, that's how you do the GSSHA model, basic overview. If you want, you can change some of these. I like to change the display options for these contours so they're color fill. Make them a little bit transparent. Oh, and the other thing is maybe don't fill below 0.001 meters or something. So anywhere that doesn't have very much water, you don't see any water. Then you can just kind of step through this. Anyway, that's kind of what you end up with.
So basically, this is what we're gonna do for the rest of the day. Is what he just did.